Okay, welcome back everybody to our next lesson on similar polygons. We're going to put to work some of our ratios, ideas about ratios and proportions. Start off by a definition of similar figures. So similar figures have the same shape, but not necessarily the same size. So it'd be like going to a photocopy machine and enlarging a drawing. Okay, so on the left side here of the screen, you see two triangles numbered 1 and 2. And you see that they basically have the same shape, but they're of different sizes. So we would say that triangle number 1 is similar to triangle number 2. And that little squiggly line there means is similar to. But if you look at the right side of the screen, again, you see two different triangles, triangles 1 and 2. But this time they're not similar because they don't have the same shape. This first one is not a right triangle. The second one is. So they're not similar. And this shape, or this sign right here, is basically says triangle 1 is not similar to triangle 2. You got a little cancellation line through that similar sign, so it is not similar to. Okay, so we're going to talk about similar polygons, and we'll just kind of read what they are. So two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional or in proportion. So there's that if and only if. So this definition, remember, works both ways, if you remember the biconditional. So you see two figures there. They're of two trapezoids. The sizes are different, but they look the same shape. But to prove that they're similar, we have to go through and look at the angles and the sides. So if we look at the angles here in the two trapezoids, we see that angle A and angle E, which correspond, are congruent. They're both right angles. You can see that. Same with angle B and angle F. Oops, I didn't put those marks in there. Let me do that now. So angle B and angle F there. And then angle G and angle C are also congruent. And angle D and angle H are congruent. They're right angles. So four angles of one trapezoid congruent to four angles of the other one. Now look at their sides. So the sides that go together, that correspond. So AB, the top of the first trapezoid, corresponds with the top of the second. So that's AB divided by EF. And then BC corresponds with the right side of the bigger one. So BC divided by FG. That's your second fraction there. Bottom side of the first trapezoid is CD. That corresponds to GH. So CD over GH there is the third fraction. And then the left sides would be DA divided by HE. So that's your fourth set of ratios. And if you look at the fractions for each pair of corresponding sides, if you look at the top, you have 6 and 12. That's a ratio of 1 to 2. Look at the right sides, 5.4 to 10.8. That's, again, a ratio of 1 to 2. Look at the bottom sides, 4 and 8. That's a ratio of 1 to 2. And look at the left sides, 5 to 10. That's also a ratio of 1 to 2. So when all corresponding angles are congruent of the two figures and all corresponding sides are in proportion, then we say that those two figures or shapes are similar. Along those lines, that 1 to 2 we've been talking about is called a scale factor or a similarity ratio. You will hear both, scale factor or similarity ratio. And the definition of that is it's a ratio of the lengths of the corresponding sides of two similar polygons. So if you know your two polygons are similar, just find a couple pairs of sides that correspond and divide their lengths together, and that'll be your scale factor. Okay, we're going to conclude this lesson with one example. So here you see two triangles, and we got three questions regarding these two triangles. Triangle ABC and triangle DEF. And the first question is, are they similar? Okay, remember to say that they're similar, you got to look at the angles and the sides. So if you look at the angles, you got both triangles have a single marked angle, so A and D are congruent. Both triangles have a double marked angle, so B and E are congruent. And then the third angles must be congruent, so angle C and angle F would have to be congruent by the third angles theorem. Okay, so all three pairs of angles of the two triangles are congruent, but that's not enough to say that the two triangles are similar. You also have to investigate the ratios of their sides. So if you look at the shortest side of the The first triangle on the left here, you got 16, and it corresponds to the shortest side of the triangle on the right, which is 12. Now let's see if that fraction ratio holds true for the other two pairs of corresponding sides. The middle side of that first triangle is going to be 20. Divide that by the middle side of the other triangle on the right, which is 15. Okay, so the longest side of the first triangle is 24. And the longest side of the triangle on the right is 18. So if you look at all three pairs of ratios of the corresponding sides and reduce them, then you're going to get 4 over 3. If you reduce by 4 in that first fraction, divide top and bottom by 4. Divide top and bottom by 5 in that second fraction, so you got 4 over 3 there. Again, you're just reducing the fraction. And if you divide the third fraction top and bottom by 6, you're going to get 4 over 3 there. Oops. So both triangles have 3 pairs of congruent angles. Both triangles have 3 pairs of corresponding sides, which are in the same ratio. So that means those two triangles are similar. Okay, so the answer to the first question is yes. And we've already answered the similarity ratio. The similarity ratio is that reduced fraction there, 4 to 3. And now you want the similarity statement. So this is kind of done the way we did congruent triangles, except these are similar triangles. Just write the triangles, vertices in the correct order, the ones that correspond. So I'm going to say triangle A, B, C. Now I'm going to write that is similar to symbol, is similar to triangle. Now notice I went single mark, double mark, no mark. So I'll do the same thing over here. So triangle ABC is going to be similar to triangle D, E, F. Okay, so there's a similarity statement for those two triangles. Okay, let's wrap it up. First of all, similar figures have this, they're basically the same shape but different sizes. And then you know that when you have two figures that are similar, corresponding angles would be congruent and corresponding sides would be in the same proportion and have the same ratio. That ratio is called a scale factor or a similarity ratio. And then we wrap that up with an example. Okay, there you go. Let's go ahead and get some practice with similar polygons, and good luck.